This is number 2 on the 2007, still on the calculator portion of the FRQ. All right. So number 2 says the amount of water in a storage tank in gallons is modeled by the continuous function on the time interval from 0 to 7 hours, where T is measured in hours. In this model, rates are given as follows. The rate at which the water enters the tank is F of T equals 100 T squared sine of root T gallons per hour for 0 to 7. So you can assume that's F of T because that's a continuous function, because then G of T is a piecewise function. The rate at which the water leaves the tank is G of T, and there's 2 pieces. So it is leaving water and leaving the tank, and this is leaving the tank. So for this particular problem, I would strongly suggest you color code this so you can see the relationship between these. So water is coming in at F of T. This is the water coming in. This is my pink. All right, this is water entering the tank. So water is leaving. This is my water leaving function, okay? All right, so despite that, the graphs of F and G, which intersects at T equals 1.617, so it's right here, 1.617, and T equals 5.076, are shown in the figure above. At T equals 0, the amount of water is 5,000 gallons. So this is important that we started with 5,000 gallons, all right? So how many gallons of water enter the tank during the interval between 0 to 7? Round your answer to the nearest gallon. So we know that water entered the tank with this function. This is the rate at which this happens. So if you want to find the total, right? So rate is how fast it went in. So if you want to find the total amount at the end, you want to take the integral of the rate, because it'll give you the total amount throughout that entire time. Because you don't know what is happening at each of the minutes. So if you do integrals, it is adding up every single minute between 0 to 7 hours, every single minute, every single second of the water coming in, and adding it all up. So it'll give you the total amount of water coming into the tank. All right. So with part A, you simply set up the integral from 0 to 7, and with this rate of water coming in, right? And dt, dx, same idea. All right. So now what do? We now take our calculator, and again use math 9, because that's why this is the calculator portion. Math 9, 100 T squared, x squared, same idea. So x squared sine square root of x, close your parentheses, 1 closing for the root, 1 closing for the sine. Again, if you have a newer calculator, you don't have to worry about so much. Comma x, comma 0, comma 7, close your parentheses. Double check your mode is correct. So mode, I am on radians, I'm good. So I press enter. And let's see, it's taking a while to calculate. I'm just going to quickly check. Round your answer to the nearest gallon. So I have 8,263.8. That will round up to 8,264 gallons of water. All right. Okay, moving on. For 0 to 7, so between this interval, find a time interval which the amount of water in the tank is decreasing. Give a reason for each answer. So think about it. When will the water be decreasing? Well, you're pumping water, and water is also leaving. So water is entering and water is leaving. So the water level will decrease when you have more water leaving than you have entering. Makes sense, right? Because if you're pumping and you're not pumping enough, more of it is leaking out, then your water level will decrease. So how do we check for that? Well, it's when water leaving is greater than water entering, which means we're looking for when the blue is bigger than the pink. Blue is higher than the pink. So if you cover your graph up like so, you can look at it from 0, right? From 0 and on, do you see how the blue is on top of the pink? So at this point, this is when the water is going to be lower level, because your blue, you have more water leaving than you have entering, right? Now, when does that change? Well, at 1.6 something hours, you have more water coming in. So now more water is coming in than leaving. That means your water level is going to rise. Well, it's going to rise until what happened? Well, at T equals 3, I now again have the blue on top of the pink. So now I again have more water leaving than the water entering, right? And again, that continues to happen until at 5 hours, because then it switches around, and now I have more water entering than more water leaving. So you can really look at it into 4 different sections. This first section is when water leaving is more. And then here I have more water coming in. But then here again, I have water leaving is more. So when are the intervals that satisfy part B? This first interval between 0 and 1.617. And then the second interval between 3 hours and 5.076 hours. Because that's when the water leaving is greater than the water entering. So give an explanation, right? So when G of T is greater than, not less than. When G of T is greater than F of T, that means the total water is going to decrease. Oops, sorry, let me move it up. So when the water leaving is greater than the water entering, total water is going to decrease. Therefore, these are in the intervals of 0 to 1.617 and between 3 and 5.076 hours. All right, so this is when the amount of the water is going to be decreasing. So in the intervals in these hours, the water in tank decreases. Okay, all right. Last but not least, let's see, part C asks you, at what time is the amount of water in the tank greatest? All right, so we don't want to look at when the water is the lowest. These are when the water is lowest. We're looking at when is the water greatest, right? Because here in this interval, at the end of 3 hours, notice how I have a lot more water than leaving. Same thing at the end of the 7 hour, I still have more water than leaving. So I need to check, right? What gives me the most? So let's see, you're going to check 3 things. You want to check at the beginning, right? At the very, very beginning, it tells you we started the water at 5,000 gallons. Okay, so in part C, we are looking at when T equals 0, I have 5,000 gallons of water. All right, so I'll look at the end of 3 hours. So at T equals 3, I started with 5,000. I added 0 to 3 of my beautiful function 100 t squared sine of root t, dt, right? But then don't forget, I have water leaving. So what is the water leaving? This function is 250 for 0 to 3. So minus 250 times 3, right? So this is water entering, water leaving, original. So that would give me a good total. At the end of 3 hours, I have 5,126.59 gallons in the tank at the end of 3 hours. Okay, so then more water's, after that, more water is leaving, then more water is entering. So you continue on. And then at the end of the 7th hour, I am once again having more water come in. So let's see if that will kind of give us the most. So at the end of T equals 7, right? You have 5,000 that you started with, plus we got the answer already from the previous problem, right? So we can go ahead and, let me back that up. We don't want to use 0 to 7 because you have this piecewise function. So you want to start at T equals 3, because at T equals 3, your water leaving is now leaving greater. You're leaving at 2,000 units, right? So at T equals 7, you want to start where T equals 3 is. So 5,126.56 plus, all right, the water coming in from 3 to 7 of 100 t squared sine of root t dt, right? But now minus the function of 2,000 times 3 to 7, that's only 4 hours. So times 4, right? And this will give you a final number of 4,513.81. So we started with 5,000, then water left, more than coming in, add more water. So at the end of 3 hours, I'm at 5,100 gallons. And then more water leaving with water coming in, and I had more water coming in at the end. So I ended up with still a little bit less than I began. So to answer the question, to nearest gallon, compute the amount of water at this time. So for what time is the water in the tank greatest? So water is greatest at t equals 3 hours with 5,120, it says nearest gallon. So if I round this, 27 gallons. Okay, that's it for number 2.